Okay, in this video I'm going to show you how to create this sheet metal enclosure in SolidWorks using the sheet metal toolbar. So the first thing that you have to do is start a new part, verify your units. In this case it's millimeters, grams, and seconds, and the material is plain carbon steel. So let's minimize this, and I've got a new SolidWorks part open. I have already changed the units to millimeters, grams, and seconds. My overall drafting standard is ANSI, and the material has been changed to plain carbon steel. So the first thing I want to do is locate and insert the sheet metal toolbar. So I'm going to navigate up to the View drop-down menu, select Toolbars, Sheet Metal. I am going to pin the sheet metal toolbar just to the left of my feature manager. There's a lot of tools and functionality with the sheet metal toolbar, and I don't want it taking up too much space. So the first thing we want to do is sketch a 200 millimeter line, which is going to be the length of this enclosure. So I'm going to do that by sketching on the front plane. I'm also going to make sure that the line stays in the middle. So I'm going to sketch a horizontal line just above the origin. I'm going to make it 200 millimeters long, and I'm going to add a relation that glues the origin to the midpoint of this line. And when I'm done, I like to revert to the isometric view so that I can see which direction my sheet metal will be extruding. So with the sketch selected in my feature manager, I'm going to click the Base Flange tab button. This is going to take that line and add a thickness and a width all at the same time. So if I knew what the sheet metal parameters were, if I knew what the gauge thickness was, I could come here and choose from a library of gauge thicknesses. Sheet metal is not plate. It is a completely different animal, and the thicknesses are driven in gauges. But for all intensive purposes, let's make the thickness 1.2 millimeters. Sorry, yeah, 1.2 millimeters here where it says sheet metal parameters, the thickness. The direction I want to say mid-plane, and I want that to be 110. So what I've done is I've taken that 200 millimeter long line, I've extruded it using a mid-plane of 110, and the sheet metal thickness is 1.2. The rest of the information can be left as default regarding the K factor and the reliefs in the corner. When you're bending sheet metal, sometimes you need some reliefs so that the metal doesn't tear. Hit the green check mark, and on the left-hand side in your feature manager, you'll notice the sheet metal functionality has been lit up. Your base flange is there, and then you have this feature called flat pattern that is suppressed, and we'll get back to that later. So perfect time to save your file. So do a quick file save. You'll notice that your sheet metal toolbar is lit up with all of the features that you can add to this base flange. The next thing that we're going to do is add an edge flange. So edge flange is a common feature used in sheet metal. All I have to do is select a linear edge, and a flange will appear at 90 degrees. So I am going to hit the edge flange button, and in this blue box where it says flange parameters, I want to select a linear edge. So I will select, I'll zoom in so you guys can see this. I'm going to select this upper edge, And we'll zoom out. And depending on where I bring my cursor, it's going to create a 90-degree flange. If I drop my cursor here, you'll notice the preview of the flange. If I wanted my flange to come off at an angle, I could type an angle other than 90. But let's set that back to 90. And we'll go straight down. And we'll go straight down at a distance of 40 millimeters. Okay, leave all of these options default, virtual, outer sharp, and the flange position where the material remains inside. I'll zoom in. If I click these options, you'll notice the sheet metal is bent in different locations, either conforming to the inside dimensions or the outside dimensions. So it all depends on what you want to get out of your sheet metal part and how you want it bent. Okay, I'm also going to click down here where it says trim side bends. I'm going to hit the green check mark, and I want to add that same exact flange to the other side. So I'm going to go back to edge flange, and the reason why I'm not mirroring this is because oftentimes you may want one side longer than the other, or you may want to make modifications to one side, and it's a lot easier if each one was independent. And it only takes a few seconds to add a second one. So we'll do it like this. All right, so now my sheet metal part is bent on the sides. Now let's take a quick look at what flat pattern does. So I'm on the left-hand side, I'm going to right-click on flat pattern, and I want to select unsuppress. So what it does is it flattens the box so that I can see what the piece of sheet metal would look like before it's bent. And this is what a manufacturer would use as a pattern. So they would either laser cut this, water jet cut this, stamp this out of a large piece of sheet metal. And then these dotted lines represent where the material is going to be bent. So let's suppress that and get back to the part. So perfect time to click File, Save. All right, next I want to add some edge flanges to the front and back of this enclosure, or the top and bottom. So I'm going to go back to my edge flange button, and this time I'm going to select 3 linear edges. So I'm going to select this one and bring it inboard. I'm going to select this one and then this one. So the 3 outer linear edges. And you'll notice what SolidWorks is doing is it's adding a gap, and it's adding reliefs in the corners so it doesn't tear. My gap thickness, I'm going to change to 0.5 millimeters. And everything else can be left as default, except the length is going to be 40. No, my length isn't going to be 40. I'm sorry. It's going to be 20. Actually, it's 18. I should have paid attention. All right, that's okay. You can see my mistakes. All right, 18. So again, I chose these 3 outer edges. I added a gap of 0.5 millimeters. Fumbled around a little bit, but changed it, the flange length to 18 millimeters. And when you hit the green check mark, you'll notice that those edges have been flanged and bent inward. I want to do the same thing on this side, hopefully without any mistakes. So I'm going to grab edge flange. Everything here should be, no, we'll have to change this back to 18. And let's do this, and this, and this. All right, so looks like that keeps changing. All right, so that might be the last thing you want to do is change the flange length. The gap is 0.5, the flange length is 18, it's bending at 90. We'll hit the green check mark. And at this point, you can review the flat pattern again. So by unsuppressing it, you'll see what it looks like before it's bent. And then here's what it looks like after it's bent. Okay, another perfect time to do a quick file save. All right, we're going to add holes using Hole Wizard. So let's come over here and look. We've got 4mm holes, and they're located at 10 in and 9 over there. So let's add these 3 holes, or these 3 points, using Hole Wizard, and then locate them last. So remember, when using Hole Wizard, you have to first pre-select the surface you want to put the hole on. Whether I select this surface, or this surface, it doesn't matter, because they all lie on the same plane. They're all flush with one another. So with the surface selected, I'm going to select Features, Hole Wizard. I want a plain drilled hole. I want anti-metric, drill sizes, 4mm, through all. If I place the 3 holes on these surfaces, they will pass through the top of the enclosure at the same time. Again, you want plain hole, anti-metric. Underneath type, you want drill sizes. Underneath size, you want to find the 4mm diameter, and you want your end condition to say through all. Make sure there is nothing selected under options. Now I'm going to select the Positions tab. I'm going to revert to my normal to view, and I'm going to place these 3 points. So I'll put one here, and put one here. Right away, I want to add a relation that makes these bottom 2 points horizontal with one another. And then I want to add a relation between the origin and this point to make them vertical, these 2 points vertical. All right, now I'm going to add my dimension of 9 for this point. So that point is fully defined. And let's go back to this drawing, and we'll see that it's 10 up from the bottom. So from here to here, it's 10. And from the outside of the box to the location of the first hole is 9. There we go. So now I have dimensions and relations controlling the locations of these holes. When I hit the green check mark, those holes are going through everything. Perfect. Okay, so isometric view, and do a quick file save. And we're moving on to the last part, which is an extruded cut window. So I'm going to sketch on the top surface of the part. I'm going to draw a window. And I want to try to use chamfer. So in this case, it's a 5 by 2.5 chamfer. So let's go to Sketch Chamfer. And instead of angle distance, we want to make sure that it says distance. And you have to uncheck equal distance. So we want 5 by 2.5. So let's say 5 by 2.5. Now, whenever you have a chamfer that has distances that are different lengths, you have to pay attention to which selection you choose first. So if I choose this line, the vertical line, and the horizontal line, you'll notice it did this. It gave the length of 5 first, and then the shorter side on the top, which is what we want. So if I had selected this line first and then that, this triangular chamfer would be different. Okay, so let's try this side. Oh, looks like you can only do one at a time. That's a bummer. That's okay. Let's go back here. Perfect. We'll do it another time. And if you guys find a quicker way of doing this instead of one at a time, by all means. But because I am being recorded, I don't want to fumble around with that while you guys are watching. Okay, so let's say we've got 40 by 20. So let's fix that. 40 long by 20 wide. And it's 30 from the front and 30 over. So 30 to there and 30 to there. Perfect. Fully defined sketch. Let's extrude cut that all the way through. All right, quick file save, and let's unfold this by unsuppressing our flat pattern and look at the top view, and that is what the sheet metal enclosure would look like as a flat pattern. So there it is. There's the PDF that's on canvas. Here's the completed sheet metal part flattened out, and let's make sure that we did this right. If I go to the Evaluate tab, I want to calculate the surface area, okay? Because chances are this entire enclosure would be stamped out in one shot on a machine just like this. The holes, these V-notches, and the window would all be stamped out at the same time. So the surface area is what most fabrication shops calculate when figuring out how long it's going to take, how much the tooling costs, and how much material that they're going to need for the enclosure. So I'm going to pre-select this top surface, and I'm going to select section properties, and I should get a surface area of 41,183.9 millimeters squared. So about 41,000 millimeters squared. That's my surface area. Okay, about that. And let's suppress that back again. All right, so that's how I would build this enclosure. There's a lot more tools available to sheet metal, but this exercise is a good practice part to mess with edge flanges and base flanges. Okay, thank you.